Hi, I'm Daniel. We're going to talk about thermal management for aerospace composites using simulation. A composite is a material made from two or more different materials that when combined are stronger than those individual materials by themselves. Aerospace composites are made from two parts, a epoxy resin matrix reinforced by woven layers of carbon fiber. A mold is used to help form the carbon fiber into different shapes. It has a high strength to weight ratio, making it a popular material for aerospace. This is what the final product looks like. But what about the processing involved to get here? To process a large composite part, you have to heat it up inside a giant pressurized oven like this one to fully harden the epoxy resin matrix. Inside this giant oven, called an autoclave, is where thermal management becomes important. So let's look at the basic problem. Curing a composite is like baking a pie in an oven. You have to bake it until it's fully cooked. If a pie gets too hot, it will burn. If the temperature doesn't get high enough, it won't be fully cooked, and time is money, so you want to cook it as quickly as possible. The problem is we don't have a recipe book, and we really don't know how to best bake the pie in the shortest amount of time. To develop the best recipe, we might have to waste hundreds of pies, so that's where simulation can help. Shown here are three criterion that are established to guarantee part quality, and our objective is to decrease the time each part spends inside the autoclave. Using the analogy from before, simulation software allows us to essentially bake hundreds of pies to come up with a recipe with the shortest baking time. The first simulation shown uses the manufacturer recommended parameters. It fails to meet the requirements and takes 330 minutes. Using the simulation software, hundreds of simulations were run to optimize the cycle, reducing that time by 48% while meeting our quality criterion. So ultimately, what is the impact of reducing the cure cycle time? Based on our simulation data, we can achieve a 160% increase in the production rate when we optimize the cure cycle using simulation. Now imagine optimizing the cure cycle for every single composite component on an aircraft and the resulting overall increase in productivity.